box, this is your oil controller, your oil level flow, and all of that obviously is tied into your pneumatics. Everything's pneumatically operated. You can go with electrical, which is a big upgrade and a big expense, which is very nice because it's it requires less operators, but with the pneumatics, it's a tried and true way. You're going to use the gas. That's what we're doing here. This is the thief port. We're using the gas, running it through a little scrubber in the corner here. That scrubber is what operates all the valves and the pneumatics in this control room. So we don't have to get external power from anywhere. This unit, that's what's so cool about it. This unit, all units really, they operate themselves. Like supply gas and all that. That's not really anything special or anything different than everybody else. It's what goes through here. It's how clean it goes through here and how long each one of these components will last. Just because you're not running that much sand through it, it's really clean. You get clean gas. You've got everything that we have has bypasses and manifolds to tie whichever direction you want. You can blow down to every single line. That's what this crossover line here is for. You can blow down your oil line. You can blow down your water line. If you get this, say this here's your oil. If you get it packed off, you get sand for whatever reason, you can blow it down. You can shut valves, open that valve, and you can blow this line back down, and you'll push everything back through the unit, throw a little bubble in it, clean your lines, and go back to running. Same thing with this here. This is a Y strainer. If you open this valve while it's running, if this Y strainer starts to pack off, this is tied in to your bypass, so you can just open your valve, run through the bypass, and keep on running. Without this line being there, you'd have to run through bypass and not continue to meter your stuff, and then you'd be just throwing oil down the line and not metering it. So your operator's not going to be happy when you're not metering what you're throwing down line. You have to be able to, at that point you would isolate, take this apart, clean it, put it back together. This is hopefully going to eliminate some downtime, which it does. It eliminates the downtime. This here's our scrubber manifold. One thing that's a little bit nice about this one is our supply gas coming in here. You can control every regulator's gas off of this tree. A lot of times what you'll see is just one regulator for this whole tree. So if you wanted to run additional valves or additional specialty equipment, you have the capabilities to control every single piece of equipment, what kind of pressure you're putting to it, whatever. Whereas typically you'll just have one pressure gauge and they'll all be set at 30 pounds and just run off of 30 pounds. And it's the little things that are nice and tidy, like our stainless and all that is nice and tidy and ran over to the wall and dropped in all nice and neat. Obviously it's not done, but it's dropped in nice and neat. There's a lot of units that I've been in where it's just thrown in there and your stainless is right in your way. Every time you change a component, every time you have to do something, you've got to reroute your stainless because it's in the way all the time, So we try to keep it out of the way and run it up, keep it clean.
In this unit we have double redundancies. We have a valve at the regulator, and we also have a valve at the HPMVs, all the heaters, so you can turn the valve off at whatever you're working on and back there in case a valve goes bad.
Yeah, because believe it or not, right here to this unit, this is a 720 PSI unit and it's a 120 PSI unit. But if you don't have a double redundancy on your valve, you just have one valve. If this valve fails, you're throwing 700 pounds to that unit. Just because that's 120 doesn't mean, and that valve's rated at 120. If it fails, it's going to throw everything it can. It can't regulate what's going into it anymore. So double redundancies, like you said, like even on these heaters and all that, we have a valve right at the heater, so you can isolate that heater and change it. That's just nice little features so that it's easy to service it, easy to use it. And all the units that we work on, typically that valve isn't there. They'll just have one line ran to it and they're all off of one line, or they'll run several valves off one line. So if one valve goes down, you have to shut the whole system down. You can't isolate, work on something, and keep going at the same time. So this unit is designed for minimal downtime. If you can isolate, work on a valve, you can isolate, work on a fitting, whatever you